Your brain is shrinking right now as you listen to this. After the age of 50, the human brain loses roughly 5% of its volume every decade. By the time you reach 70, your brain is measurably smaller than it was at 40. Not damaged, not diseased, just smaller. And if that sounds alarming, I understand. It alarmed me too when I first read the research. But here is why I am telling you this. Because the shrinkage is not equal. It does not happen everywhere at the same rate. And the parts that shrink fastest are the parts you use most. Your memory, your ability to plan, your capacity to learn new things. But here is the other side of that research, the side that rarely makes the headlines. The brain that is shrinking is also the most adaptable organ in your body. It can grow new connections at any age. It can strengthen the pathways it still has. And there are 3 specific things backed by decades of research that measurably slow the rate of shrinkage, not stop it, slow it. And the difference between a brain that shrinks at the normal rate and one that shrinks at a slower rate is the difference between independence and dependence, between remembering your grandchildren's names and searching for them. Let me take you inside your brain and show you exactly what is changing and what you can do about it. To understand what is happening, you need to see the difference between a young brain and an aging one. And the difference is more visible than most people realize. A brain at 30 is at its peak volume. The cortex, the wrinkled outer layer that handles thinking, language, memory, and decision-making, is thick and densely packed with neurons. The white matter beneath it, the billions of insulated fibers that connect different brain regions, is intact and fast. Signals travel quickly. Connections are strong. The brain weighs roughly 3 pounds and fills the skull almost completely. Now look at a brain at 65. The cortex is thinner. The grooves between the folds, called sulci, are wider. There is more space between the brain and the skull, filled with cerebrospinal fluid. The white matter has begun to show tiny lesions, small spots where the insulating sheath around nerve fibers has degraded. Signals still travel, but they are slower. Some connections that were once strong have weakened. This is not Alzheimer's disease. This is normal, age-related brain atrophy. It happens to everyone. Albert Einstein's brain shrank. Stephen Hawking's brain shrank. Your brain is shrinking. The question is not whether it happens. The question is how fast. And the speed varies enormously from person to person. Some people at 75 have brain volumes comparable to 60-year-olds. Others at 65 already show volumes typical of 80-year-olds. The same age, dramatically different brains. That gap is where your choices live. The 2 regions that shrink fastest are the prefrontal cortex and the hippocampus. These are not random areas. They are the command centers of your daily life. The prefrontal cortex sits right behind your forehead. It is the most recently evolved part of the human brain, and in many ways, it is what makes you, you. It handles executive function, the ability to plan ahead, make decisions, resist impulses, and hold information in your working memory. When you decide to put down the cookie, that is your prefrontal cortex overriding a deeper impulse. When you remember what you went to the kitchen for, that is working memory, powered by the prefrontal cortex. This region begins to thin as early as your 40s. By 60, most people have lost measurable thickness in this area. The effect is subtle at first. You walk into a room and forget why. You start a sentence and lose the word you were reaching for. You find it harder to focus when there are distractions. None of these are signs of dementia. They are signs of a prefrontal cortex that is thinner than it used to be. The hippocampus is deeper inside the brain, in the temporal lobe. It is shaped like a seahorse, which is where it gets its name. And its job is extraordinary. The hippocampus is where new memories are formed. Every face you remember, every name you learn, every experience you store, passes through the hippocampus first. The hippocampus shrinks at a rate of roughly 1 to 2% per year after the age of 50. That may sound small, but compounded over 20 years, it represents a significant reduction in the brain's capacity to form and retrieve memories. This is why people over 65 often remember their childhood vividly but struggle to recall what they had for lunch yesterday. The old memories were stored long ago by a larger hippocampus. The new memories have to be processed by a smaller one. Research from the Rush Memory and Aging Project, which has followed over 2,000 older adults for decades, found that the rate of hippocampal shrinkage is one of the strongest predictors of cognitive decline in later life. Not the only predictor, but one of the most reliable.
So what can you actually do to slow this process? The research points to 3 interventions that consistently produce measurable results. And the first one might surprise you because it has nothing to do with brain games or supplements. Solution number 1. Physical exercise, specifically aerobic exercise. In 2011, a landmark study published in the Proceedings of the National Academy of Sciences changed how neuroscientists think about the aging brain. Researchers at the University of Pittsburgh took 120 older adults and divided them into 2 groups. One group did moderate aerobic exercise, walking briskly for 40 minutes, 3 times a week. The other group did stretching exercises only. After 1 year, the walking group's hippocampus had increased in volume by roughly 2%. The stretching group's hippocampus had decreased by roughly 1.5%, which is the normal expected shrinkage. In other words, 1 year of regular walking did not just slow the shrinkage, it reversed it. 2% may not sound like much, but remember, the hippocampus normally shrinks by 1 to 2% per year. This means the walking group effectively turned back their brain's clock by 1 to 2 years in 12 months. And the improvements were directly correlated with improvements in spatial memory. How does walking change the brain? Exercise increases blood flow to the brain, delivering more oxygen and nutrients. It triggers the release of a protein called brain-derived neurotrophic factor, or BDNF. Think of BDNF as fertilizer for brain cells. It promotes the growth of new neurons in the hippocampus, strengthens existing connections, and protects neurons from damage. You do not need to run marathons. The study used moderate walking, 30 to 40 minutes, 3 to 5 times per week. A pace where you can still hold a conversation but feel slightly out of breath. That is the dose that changed the hippocampus. Solution number 2. Deep sleep. In my video about why you wake up at 3 in the morning, I showed you the glymphatic system, the brain's cleaning mechanism that activates during deep sleep. Brain cells shrink by 60%, allowing cerebrospinal fluid to flush out metabolic waste, including beta amyloid, the protein associated with Alzheimer's disease. Here is what I did not tell you in that video. The amount of deep sleep you get directly affects the rate of brain shrinkage. A study published in the journal Neurology in 2023 followed nearly 300 older adults over several years. Those who spent less time in deep sleep showed faster rates of brain volume loss, particularly in the prefrontal cortex and hippocampus, the exact regions we have been discussing. Deep sleep is not optional maintenance. It is structural preservation. Every night of poor sleep is a night where toxic waste accumulates in your brain tissue and structural damage progresses slightly faster. The strategies I gave you in the 3 a.m. video apply directly here. Bright light in the morning, cool bedroom, consistent sleep schedule, limiting blue light in the evening. These are not lifestyle tips. They are neuroprotective strategies. Solution number 3. Social connection. This one is the least expected and possibly the most powerful. A major study published in Neurology in 2023, the same journal, analyzed brain scans from over 11,000 adults. People who reported feeling lonely showed significantly greater brain atrophy, particularly in the hippocampus, the amygdala, and regions associated with sensory processing. Loneliness does not just feel bad, it physically shrinks your brain. The mechanism appears to involve chronic stress. Social isolation activates the stress response, elevating cortisol for extended periods. And chronically elevated cortisol is toxic to hippocampal neurons. It literally kills brain cells in the region you need most for memory. The reverse is also true.
People who maintain strong social connections, who talk regularly with friends, who participate in group activities, who feel a sense of belonging, show slower rates of brain atrophy and better cognitive performance as they age. The brain needs other brains to stay healthy. Let me bring this together with something I want you to remember. Your brain is not falling apart, it is adapting. Like your knees, like your arteries, like every part of your body, it is changing with age. And like every other part of your body, the speed and severity of that change is not entirely fixed. You have influence over it. Move your body. That is the single most powerful thing you can do for your brain. Not brain training apps, not crossword puzzles, although those have their place. Physical movement, walking, swimming, dancing, anything that gets your blood moving and your heart rate up. 30 minutes most days. The hippocampus responds. Protect your sleep. Deep sleep is when your brain cleans and repairs itself. Every strategy that improves your deep sleep is a strategy that slows brain atrophy. Go back to my 3 a.m. video if you need the specifics. Stay connected, talk to people, join a group, call a friend. The brain that hears another voice, that laughs with another person, that feels understood, is a brain that shrinks more slowly. Loneliness is not just an emotion, it is a neurotoxin. These 3 things will not stop your brain from changing. Nothing will. But they can slow the process measurably, meaningfully, and in ways that protect your independence, your memories, and your sense of self for years to come. In my next video, I am going to show you the best breakfast for brain health after 65. What you eat before 9 in the morning changes how your brain functions for the rest of the day. And some of the foods that help most are not what you would expect. Subscribe so you do not miss it. I release a new inside story every Monday and Thursday. Your body is changing. Let us understand it together. Take care of that beautiful brain. I will see you in the next one.